Well, we're carrying on with probability, okay? And in probability, last week we spoke about the most important formula in probability, which is the number of, whenever you have a uncertain question, you have a number of possible outcomes and a number of favorable outcomes. Give me a thumbs up if you remember this fundamental equation. Relo Bukhadi, I see your hand is up. Do you want to unmute and then we can have a chat? While we're waiting for that, so that is the main rule in probability. But now, oh yes, hi.
Oh, I'm sorry, I was having a technical difficulty.
Okay, no worries. You can just speak to Kia in the chat and we'll get that sorted. Okay, so now today's lesson is really focusing on how do we count the number of possible outcomes and how do we count the number of favorable outcomes. And one of the tools that we use is something called a Venn diagram. And so we're going to get to that shortly. Now, something else that comes up quite a lot in probability are these two equations and this notation. So what you see here is sometimes you see the word or, and the word or can also be said like a happy face. And sometimes you see the word and that you see as an unhappy face. So in this, that's the unhappy face. That's an and this one over here has been written as an or. Now, this is called the additive rule for probability. And I just want to apply it to a Venn diagram to make sure you understand what it says. So there's two ways of writing it. The one is with an N. I want to ask you in the chat, what does the N stand for? What does the N stand for in probability? Let me know in the chat what you think the N stands for. So the N in front of the A and B or things like that. So the N, pop answer in the chat. I want to see what people think the N stands for. If you don't know, that's fine. That's why you're here. So just say, I don't know. Number, yes. Okay, yes, the N stands for number. So if I said to you, looking at this Venn diagram, which has different events in it, what is the N of A? Could you tell me what the N of A is? Could you tell me what the N of B is? Tell me what you think in the chat. What is the N of A? How many items are there? This is saying how many items are there in the event A? How many items are there in the event B? So the whole of A is actually all of this. And the whole of B is actually all of this. The number of items in A is actually going to be 4. 1, 2, 3, 4. How many items are there in B? One, 2, 3, 4, 5, 6. Yes, that's true. Now, what about if I said to you, how many items are in A and B? Or another way of saying this is using the smile notation. How many items are in A and B? Remember, and means you must be in A and you must be in B. Each of these circles represents the event. Well, that's the event A, that's the event B. If you're in A, it would be all of these ones. If you're in B, it would be all of these ones. How many items have 2 colors? how many items have two colors over them? To me, the only ones that are in A and B are those two items. And so we'd say that the n of A and B is 2. Yes, Amukalani and Kumo. I like what I'm seeing. I like what I'm seeing. Now, what about if I say to you, what is in A or B? Or if I was using this notation, it would look like this. So it can be in A, or it can be in B, or it can be in both. How many items are in A or B? So there's 2 here, there's 4 here. So that's 6, there's 2 here. So there must be 8. Now, this is fantastic news because this shows us what this law actually says. So how many items are in A or B? Well, you just told me that that is 8 items. How many items are there in just A? Well, there were 4. How many items were there just in B? There were 6. Now, what happened now is, can you see 4 plus 6 is 10? And that's way bigger than 8. So why has it got bigger than 8? Can anybody, for this is a tricky question, why, when I'm adding up how many items in A, how many items in B, why is it bigger than the 8, which is the total number of items inside the circle here? You can put your hand up or you can put it in the chat. There's one little bit we have to do to adjust this. So what I think has happened is that when we added up A, we counted the 3 and 9, and when we added B, we counted the 3 and 9 again. So we've counted this middle bit twice. And so in order to deal with that, we have to take away the n of A and B, which is 2. And now we can see that the equation works. So give me a thumbs up if you followed how I did, if you kind of get what this law is saying over here. Give me a thumbs up. Give me a thumbs down if you don't really get what that law is saying. Okay. Fantastic. Now, the last one I want to say is, what is the n of S? What is the n of S? Now, S is there's no S on the drawing, but S is the whole sample space. So what is the n of S for this particular Venn diagram? So S is literally everything in the whole rectangle. So literally, in fact, there is an S there. You can see at the top. So I want to know how many items are there in this whole space. Now, you know how many there are inside the circles, but there could be some that are outside. So we know that there's 2 here, 4 and 4. So, no, sorry, 2, that's 4, that's 8. But then I go outside and I count 9, 10, 11, 12. So the n of S is 12. Now, why this is going to help us is I'm going to ask you this question. Find me the probability of A and the probability of B. So in this question, I'm now asking you, if you chose a random number from this collection, what is the probability that you would choose a number that falls in the set A? Write down what you think the answer is. On the board, you have enough information to help you, but I want to see if you can connect what it means to use the letter P instead of using the letter A. So what is the probability? If you choose a random number here, you end up in A. Zandile, I see your hand is up. Or do you want to ask a question while students are working?
No, sir. I was lost, but I saw the 4 plus 6 minus 2, sir. So I'm okay, sir.
Perfect. Awesome, awesome, awesome. So there's 12 possible outcomes, and there are 4 that are in A. So there's a 4 in 12 chance. And for B, it's still going to be out of 12. But for B, it's going to be 6 out of 12. And if you simplify it, yes, if you could simplify down to a half and a third, but that for now, I'm not worried. What is the probability of A or B? What's the probability of A or B? So what we're saying is, if you choose a random number, what's the probability you end up inside the circles? 1, 2, 3, 4, 5, 6, 7, 8. So we're going to get 8 out of 12. Yep, that's looking good. What about, I like what I'm saying. So there's 8 in there. Now the last one, what's the probability of drawing a number that is in both A and B? What's the probability of drawing a number that is both in A and B? So this is getting a bit predictable. Hey, it's out of 12 and it's there. Fantastic. Now look at how this connects to this identity you can always use in probability theory. The probability of A or B is 8 out of 12, and it is equal to 4 out of 12 plus 6 out of 12 minus 2 out of 12. And all this is just the one we did before with the 12s on the bottom. But the good news is, if they give you questions where they give you this one, and they give you this one, and they give you this one, you can always work out the missing one. Okay, and so I just want to stop for a quick vote of hands. Does everybody understand how, or tell me in the chat with a vote, if you understand what this identity means and how it's connected to a Venn diagram? Now, what you're going to find is that these identities are going to come up a lot. If you are confused, you can always rewatch this bits, but I promise you there's so much knowledge sitting in this little section here. One more question before I move on. If I say to you, what is the probability of B dash? Can somebody tell me what that even means? If I say to you, find me the probability of being in B's complement, or find me the probability of not being in B, can anybody tell me what they think goes into the fraction? What's the bottom fraction going to be for this? What's the bottom fraction? Well, the sample space is 12 items, so that's 12. Now, how many items are in sample space but not in B? And I'll highlight where B is. B is this. Now, how many items are there that are not in B? Now, I'm showing you what B is. If you're not in B, you are outside of B. So I can see one there, 4, 5, 6. So it feels to me like the probability of not being in B is going to be equal to 6 out of 12. And we call, if you think of B and B dash, these are complementary sets, and they will add up, well, let me do it like this. The n of B plus the n of B dash will equal just 6 plus 6, which is 12. And then the probability of being in B is just going to be 6 over 12. And the probability of being in B dash is also going to be 6 out of 12. And together, they sum together to give you a probability of 1, or 12 out of 12. And these are called complementary events. Okay. Okay. Give me a thumbs up if you feel like you understand what a complementary event is. Give me a thumbs down if you feel like you don't understand what a complementary event is. Sometimes they write the rules like this. Oh, it's a bit bigger. So if you're feeling a bit confused, they use the letter A, not the letter B, but that's just kind of what I'm trying to give you a taste of. Okay, fantastic. Guys, you are doing so well. Let us go to a question. I'm going to go over it in this question now. So here is our Venn diagram question. I want you to, there are a group of 27 girls and 10 play netball and the rest do not play netball. I want to know how many in the group do not play netball. And I want you to put it into your own Venn diagram. So I want you to do that. So A, and I also want you to draw your own diagram. And when you're done, just say done in the chat. Terrell, I'll try. Terrell, maybe just take a screenshot. Can I just say take a screenshot from the recording? I think I've scrolled up a little bit too much. Okay. But we'll have to get from the recording. Yeah. Okay, represent this in a Venn diagram. I will scroll up in a bit, Terrell. I'm wary of, yeah. Now, here's an interesting thing. Let me know in the chat. Say done when you finish drawing. You finish drawing your Venn diagram. Now, what I notice is 27 girls, 10 play netball, and the rest do not. Your Venn diagram is not going to have overlapping circles. So if I think of this thing, that would be N, let's say the people who do netball, and 10 people play netball. And then outside of that, people who do not play netball, there's 17, because S, the number of items in this data set, is 27. So C, are the events play netball and do not play netball complementary? Are they? Are they complementary events? So what does it mean to be a complementary event? Well, a complementary event means you don't overlap with another event, or you're mutually exclusive. I think they are. Okay, so we must go over the definition of complementary events. So if you think about this N, and this, we'll call this bit outside it N dash. If something is complementary, you're checking for two things: no overlap, and there's no overlap. If you play netball, you can either play netball or you don't play netball. It says here the rest do not play netball. So there's no overlap, and you have to fill S, or you have to fill the sample space. Both of those conditions are done here. And so actually, guys and girls, these are complementary events. Now, normally you can play more than one sport, but in this question, they said the rest do not play netball. Okay, determine what N of S is. What is the N of S in this question? What is the N of S in this question? Yep, 27. Okay. Now, what about this question over here? One of the 27 girls is chosen. Determine the probability as a common fraction the girl chosen plays netball. What's the probability that one girl out of 27 plays netball? Or that one of the girls chosen, what is the probability of N? It's going to be 10 out of 27. I love it, Conke. I love it, Mamelo. Looking great. What's the probability that the girl does not play netball? So in this case, I'm saying, what's the probability I choose someone and they do not play netball? So it's going to be 17 out of 27. And notice how complementary events, their probabilities, they always add up to 1. They fill the whole sample space. Give me a thumbs up if you feel like you have a better understanding of what complementary events are. Give me a thumbs down if you feel like the idea of a complementary event doesn't make sense. Okay. Awesome, awesome, awesome. Okay. I want you to try and do this one by yourself. I'll give you a little bit of help, but let's start by reading through. It says 24 learners in class were invited to Adam and Nisha's birthday party. It says 13 learners decided to go to Adam's party. 12 decided to go to Nisha's party. And 3 learners decided to not go to either. How many learners went to the 2 parties? You know what? I'm going to suggest, why don't you rather start by drawing a Venn diagram. So I'm going to give you some time. You just tell me in the chat when you are done with drawing your Venn diagram. And then we'll talk about the questions. I feel like the Venn diagram should come first, because it helps us understand what's going on. Whereas if we try to answer it without doing a drawing, our brain goes, whoa, 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 bud, settle down. So now I need to fill in these different regions. Sadiq, they wouldn't be mutually exclusive because, oh, sorry, I lied. I made a mistake, guys and girls. Look at this. So let me show you my mistake. I didn't read the question properly. It said 3 learners decided to not go to either of the parties. So the 3 doesn't go over here. The 3 has to go out here. And now we have to go inside these circles. Now, I want to ask, there's a couple of different ways of doing this. Where would we start to figure out what numbers go inside here? There's a couple of different ways. I'm interested to know. So Sadiq, they're not mutually exclusive. I don't think so, because there could be numbers in here, but we'll find out now. If there are numbers that can be in both, they're not mutually exclusive. Okay, there's 2 ways of doing this. In total, there were 20. I think the easiest way to do this is to ask how many items are there inside the circles. Now, you know there's 3 outside, and you know in total, so S or N of S is 24. 24 in a class were invited to Adam and Nisha's birthday party. I want to know how much goes inside here. Well, I was thinking inside here and here would be 21, because 3 don't go in here. These two circles need to add up to 21. Now, that's not the only way you could do it, but that's one way. Now, what I was also thinking is I don't know what is in the middle. And the last time we said that we make X in the middle if we don't know. And in that case, I think A would be 13 minus X and N would be 12 minus X. Give me a thumbs up if you followed how I went from, basically, if I look at A, if I go 13 minus X plus X, I get 13, which is what I want. If I go N is equal to X plus 12 minus X, I get the 12. So it's a sneaky way to get representations, but I still haven't found X. What am I going to do to find X? What do I need to do to find X? Who has an idea? Maybe they can share. I think I sort of did something like this in the last lesson. So I was thinking we need to build an equation using these things. So if I go 13 minus X plus 12 minus X, now your choice is you can either make this equal to 21, or you can add the 3, and that must be equal to 24. And what that is it's saying, look, there's a 3 here, a 13 minus X, an X there, a 12 minus X, and we know that there were 24 students in the class. So we know if we solve this equation, we'll get X. And so I want you to find what is X. Solve for X for me. What is X going to be?
Mr. S, I see that Mzwandile has their hand up. I don't know if they would want to say something or ask a question.
Zwandile, do you want to ask a question?
Yes, sir.
Yes. How can I help?
So when I calculate 13 plus 12, it gives me 25.
13, that's fine. But then do you see the plus 3 here? So I get X. Did you get X is 4? Yes. So did you get X is 4?
No, sir.
Okay. There is another way to do it. If you went 13 minus X plus X, let me do this. So plus X plus 12 minus X, you could have said that's equal to 21. That equation would also work because you're just staying inside the circles. Okay, but you should have got X is 4.
Okay.
All right. Now, then what we have next is, in fact, let's just finish this question off and then we'll have our break. So if X is 4, then we know, go. Okay. What we have is, if X is 4, then we said this one was going to be what? So this is 4, this is going to be 8. Oh, I made it disappear. Let me bring it back. So that is going to be 4. And then this one over here should be 9. And you'll notice 3 plus 9, 12. 9 plus 4 is 16. 16 plus 8 is 24. So tell me what the answer to this question is. That the learner only goes, so what is the probability that a learner only goes to Adam's party? I want to know what the answer to that is. What is the probability that the learner only goes to Adam's party? So here's Adam. You only go to Adam. This one goes to Adam and Nisha. So this is going to be 9 out of 24. Perfect. I want to know, what is the probability if you choose one random learner from this group that the learner goes to both parties? What is the probability that they go to both parties? And the learners that go to both parties are hiding in here. This was the X, although I don't think you can see it so clearly. So let me, there are. So this would be 4 out of 24. Yeah. And what is the probability, the last one before we have a break, that the learner doesn't go to either of the parties? What's the probability you choose someone who didn't go to any of the party? It's just going to be 3 out of 24. Okay, well done, everyone. We have made quite a lot of progress in understanding how probability questions connect to Venn diagrams. And I just want to have a short little break with you. So this is going to be a quick one. I want you on your feet, turn on your cameras, and we're just going to do a quick little shake of our arms. I want you to loosen them up. I want you to do roll your shoulders, roll them back, and then I want you to roll them forward. I want you to twist a little bit of a rotation. And again, trust me, this is going to help your learning in the second part of the lesson. Even if it feels a bit silly, it's part of the process. So yeah. Okay, and then let's do 20 jumping jacks. I mean, not jumping jacks, air skips. So we'll go in 3, 2, 1, 2, 3, 4. And have a seat. I do hope that you got some exercise. Today is going to be a shorter break because I do want to cover a bit more, and I'm not going to do a brain break today. So sorry if you're expecting that, but there's quite a lot to cover. And so I'm rather going to keep going. Let's just do a quick little bit of multiple choice. Can you tell me what region, which of the 4 options matches the colored in region? Which of the 4 options matches the colored in region? So A and B, yes. The answer should be A. Awesome. Well done. Okay, let's do. Which of these is the colored in option? So remember, it's not the one that's white, it's the one that's gray, that's colored in. What is the correct option going to be? So what this is saying is it's everything that's not in B or the complement of B, which for me has to be B dash. So B and B dash are complements. I can be anywhere I like in the sample space, but I can't be in B, so I must be in B dash. Okay. I see a few students were saying it's A, so just have a look for that. Notice how when I say the colored region, can you see how I can't be in B, that's not colored in. I can only be outside of B, which is not B or B's complement. Then what about this one? What we have here is we have 3 events that are intersecting. Now, these 3 events intersect look like this. I want to know, how would you represent this region over here? Now, it looks to me like this red bit is in A, it's in B, and it's in C. Which of the 4 options do you think will match the thing over there? Well, if you want to be in A and B and in C, in the smile notation, it would look like that. And so the correct option would be there. Okay, so it's important that you are able to identify the different regions on a Venn diagram, especially in fact, let me just show you 2 things before I move on. If I had to ask you, I'm going to color in a patch of this. What area would be colored in if I say to you that I want you to shade in the area A and B? Now, I want you to think for yourself, what region do you think Mr. Skidder is going to color in now? So take a moment. And A and B would be this whole region here. If I said to you, what is the region colored in A and C? To be in A and C, you would be in that region there. And if you had to be in the region, what's the one we haven't done? B and C. B and C would be this region here. Do you notice how the one in the middle is the only one that's in all 3? Give me a thumbs up if you feel like you have understood the different regions with 3 overlapping circles. Okay. So then let's go to a Venn diagram question. Like this one. So the survey is conducted with a group of 50. Did we do this one last time? I don't think so. A survey is conducted with a group of 50 learners to find out what is more popular at the school tuck shop. They are asked if they usually buy toasted sandwiches, T, or salads, S, or burgers, B. They can choose none, 1, 2, or 3 of the meals. So they can choose whichever combo they want. How many people did not buy salads, toasted sandwiches, or burgers? So that's your first question. How many people did not buy salads, toasted sandwiches, or burgers? I want you to think about what we've done so far today and what you can do to help yourself to do this. So I'm looking at these different areas, and this area, like, for example, the number of items in T would have to be 15 plus 2 plus 3 plus 1, which is 21. But now I actually think I know, to find this region, I have to subtract. I have to go 50 minus all these here. So I go 17, 18, 21, 31, 36, 40, and I go 50 minus 40 is 10. And so there must be 10 students who don't eat any of these. They're not in T, S, or B. Okay, then calculate the probability. Here's your next question. Calculate the probability that a learner selected at random from the survey buys salads. So let me go buy salads. Let me get a different buy salads, but not toasted sandwiches or burgers. Can you answer that question for me? So they buy salads. What's the probability this person you choose buy salad, but not toasted sandwiches or burgers? What region is that going to be? So S is here. So salads, those are the salad people, but they don't buy toasted sandwiches. So they can't be in T and they can't be in B. So the only region I see is this one over here. Because these people buy salads, but they don't buy other things. So the probability of getting that person, it's going to be out of 50, because that's how many people, and only 10 people buy salads and nothing else, which is the same as 20%. Give me a thumbs up if you followed that. Okay. See if you can do the next one. What is the probability that a randomly chosen person from this group buys toasted sandwiches and salad, but not burgers? Yeah, Napo? No, the 10 outside, they are not included because they don't buy burgers, sandwiches, or salad. So the 10 outside, they buy nothing. So they're not in the salad people group. They have to sit somewhere else at lunchtime. So probability is always about how many possible. So it's out of 50. So how many people buy toasted sandwiches and salad? Toasted sandwiches is T and salad is S. So these are the people who buy both. But I'm not allowed to buy burgers. So those people are going to send me away at lunchtime because they're like, no, you can't eat burgers here. So if you're going to eat, it looks to me like that's the only region where you buy toasted sandwiches and salad, but not burgers. And so it would be 2 out of 50. Okay, let's do another one. Same idea. Calculate the probability that a randomly chosen person buys salad or burgers or both, but not toasted sandwiches. So you may not sit here if you bring your toasted sandwiches. So buy salad or burgers, or you can buy both, but not toasted sandwiches. So I'm still out of 50, but I've got to find my region. So salad is here. And what else have I got? So salad, oh, sorry. Having a moment there. My computer's gone a bit wonky. So salad or burgers is going to be here. Because salad is S. It's not going to be there. Be careful. So S is for salad and B is for burgers. So you could be here. So salad or burgers or both. But no toasted sandwiches. So the 3, I'm afraid, gets kicked out because the only one that's left is the 5 over here. So watch out for that. You can buy salad or burgers. So salad or burgers, which is that region, or both. Now, salad or burgers. Oh, wait, sorry. Salad or burgers or both. I'm having a moment here. By salad or burgers, which is here. So it should actually be that one. So salads or burgers or both, but not toasted sandwiches. So what do we have to click out? Not toasted sandwiches. I'm afraid these guys are not welcome to the party. So they have to go missing. And so it is 19 out of 50. And so as a percentage, it would be 38%. Okay. So 38%. Give me a thumbs up if you could follow that. Give me a thumbs down if I lost you. That I'm now dealing with 3 Venn diagrams that have 3 events. So it's got a bit more tricky, but I'm still following the same basic ideas. Okay. Well, that's good. You guys are doing well here because I'm taking it up a notch today. I'm very impressed. So let us end with me showing you an example. We'll finish this off in the next lesson. But the final type of thing you need to do with Venn diagram are questions like this. So let's just go through this one together. It says Venn diagram showing 3 events. It says during a survey at a certain school, 350 learners were asked about their favorite sport. Now, I know that I'm going to have to draw a Venn diagram, so let me just start with that. Oh, I don't know why my computer went. Oh, there we go. It's come back. So here's my Venn diagram. And inside the Venn diagram, I look for the 3 events inside. They are tennis, people play tennis, rugby, and cricket. And there are some people who play all 3. Now, because I know there are some people who play all 3, when I draw my Venn diagram, I have to have a possibility of those people sitting in the middle. And so I'm going to go T, R, and C to represent these ones. Give me a thumbs up if you followed what I've done so far. Give me a thumbs up if you followed what I've done so far to set up this program, this thing. Okay, now, it says that 78 like all 3 of these sports. So the 78 is going to go right in the middle, and I'm going to put it over here. So this I'm going to cross out because I've used it already. Now it says 240 like cricket, but there's no way for me to figure out what, because there's 3 different regions. It's 180 like rugby, but I don't know how much go into each region. 180 like tennis. So I'm stuck here. I can't do anything. Where do you think I should start to try and start figuring out these other zones? Where do you think I should start to start figuring out these other zones? So I can't do here, but this looks promising. So if 60 like tennis and cricket, but not rugby, where would that be? 60 like tennis and rugby, but not cricket. So surely this bit over here has to be, so they like tennis and rugby, but not cricket. So this is going to be 60. I made a mistake. Ooh, so that's all. Where did I make a mistake? 60 like tennis and, oh, I made a mistake. Thank you. Yes. So let's go back and erase that. So you have to be very careful with these. One little thing can go a long way. 60 like tennis and cricket, I should actually be in this zone, but 60 like tennis and cricket, but not rugby. And so the 60 should be here. Thank you so much, Tegomatso. Eyes on the prize. So we've done this one. 54 like rugby and 54 like rugby and cricket. So rugby and cricket but not tennis. So there's 54 here. 30, like tennis and rugby, but not cricket. So there's 30 here. And now I want you guys to tell me what goes here. What goes in that region over there? What are you going to use from the top that can help you figure out this bit? So you know 180 like tennis. So you should go 180 minus all these. And what do you get for that? You should get a 12. Yeah. How many are going to go over here? That's the rugby part of town. So you need to go 180 minus 30 minus 78 minus 54, which gives you 18. And so that is going to be 18. What about down here? What's going to be here? So there we have 240 minus 60 minus 78 minus 54, and you should get 48. And last one, how many people do not have a favorite sport at all? Are there some people that do not have a favorite sport at all? What would they be? So you knew there were 350 at the beginning. And I think what you need to do is just subtract all of these numbers, and whatever's left must be on the outside. So what do you get? You should indeed get 50. Okay, here, if you could put the poll up, we will continue with Venn diagrams a little bit on, well, not a little bit, about 20 minutes worth on Wednesday.